completing the square. So to complete the square, essentially what we're doing is going from one form of a quadratic to another, and the forms are actually called standard and standard and vertex. So this is the parent function for standard, a x squared. I'm going to say plus b x. There's a b value, and then there's a c. Get the colors right, yay! And then we're going to go to what's considered the vertex form, which also has an a. X minus and a squared and a plus, and this is an h and this is a k. So though I use similar colors, be aware that b and h are not the same, c and k are not the same, a and a, they're the same. So those values should be the same. In other words, we know that our a value right now of our standard form is 3, so the a value in the vertex form is going to be 3 also. Major difference here is here's our b value, it's negative 12, and our c value is positive 8. So we're going to take this function and put it through something called completing the square, and that's literally just how you go from standard to vertex form. Okay? So let's take this function. F at x is equal to 3x squared minus 12x plus 8. The very first thing we're going to do is we're going to common factor the very first two terms by the a value. So the a value is 3. So we're going to common factor. We're going to take 3 out of the very first two terms. Okay, and I'm going to highlight that we're only touching the first two terms when we do this. Okay, when we do that, we end up with is equal to 3. And then in brackets, you'll have, when we divided x squared minus 4x, okay, plus 8. This 4x, consider it like your new b value. And what you do with this b value is you actually take the b value, divide it by 2, and then square it. And what you're going to do with that is you're then going to add and subtract it within the brackets. And when you add and subtract the value, you're actually not changing anything. For instance, if I add and subtract, if I do plus 1, minus 1, no, that's 0. So I'm not changing anything, but I'm making a number that's going to help us with a factoring process later. So we take this value, our new negative 4, so negative 4 divided by 2 squared, well, negative 4, I'm just going to go up here because we have room, divided by 2 is negative 2 squared, and negative 2 squared is going to be 4. So we're going to add and subtract the values of 4 within the brackets. So we have equals 3x squared minus 4x, and then we're going to go plus 4 minus 4, it's a little messy, sorry, plus 8. Great. What we're next going to do is we're going to take this negative value, and we have to take the negative value out because we can't actually factor the negative value, and we're going to take it outside of the brackets over here, okay? In order to do that, you must multiply by the a value because of distributive property. So when I take negative 4 out, just be aware we're going to multiply it by 3 when it gets outside the brackets. So next we're left with 3x squared minus 4x plus 4. Negative 4 times 3, yeah, negative 12 plus 8. Great. We'll deal with those two constants at the very end. The next step to this is factoring this here. Now this is considered a perfect square trinomial? Yes. And essentially, it's going to factor into something that's going to be the same two factors so that we can square them. So you can go through the product and sum if you want, but because we went through this very specific steps here, the very fast way to factor these is actually just take the square root of the first term and the last term, okay? If you want, we can prove it later, but I'm going to show you the shortcut. So we built a very specific trinomial. That's what this whole process was before. So I'm going to find the square root of x squared, which is x, and the square root of 4, which is 2, okay? And now, I'm going to just plug it right into our factored form. We know the a value is still going to be 3. I can technically set up 2 sets of brackets, and this will be the first term in both, so x, and the second term in both will be positive 2. Oh, I lied. So it will be 2 and 2. I can't assume it's a positive. How do I know what term to take? Well, I take the term in front of the middle, the new b value. So that negative 4, because it's a negative, I actually make these both negative. Okay, so just be aware of that. And on the outside, recall that we still had negative 12 and positive 8. Because these are the same two, we can just go 3x minus 2 squared. And negative 12 and 8 is going to be negative 4. So our vertex form, or f at x, is equal to 3x minus 2 squared minus 4. What does that mean for a vertex? We talked about this before, but the x value of the vertex is going to be the h term, and the y value of the vertex is going to be the k term. So we do our h and our k, and that means our vertex is positive 2 and negative 4. Remember, we always take the opposite of that inserted term. So how do we prove this? Let's actually go through the process of proving this. What I'm going to do is I'm going to go into our graphing calculator here. And, oops, there we go, 3, negative 12, and 8. So y equals 3x squared minus 12x plus 8. Okay, so we have a very specific quadratic here. Oh my god. There we go. Negative 2 and 4. We know that was the vertex. So remember, this was the standard form. I'm going to put in the vertex form just to confirm. Our vertex form was 3, negative 2, negative 4. So y equals still 3, this time brackets, x minus 2 squared, and then negative 4? Negative 4. Perfect. And do you see how they literally overlap each other? I turn it on and off. That means you've done it correctly. So use the graphing calculator to kind of prove this stuff. And like we said, that's the vertex that we assumed it would be.